Yep, we're good to go.
No, I'll just do some really shit out of
Right out, everybody ready? Everybody ready? Okay, we get started then. So, what I'm going to do this morning is just go through the solutions to the lab. And I had a bit of a crazy idea to show you a really cool thing called processing. So we'll see how we get on time-wise. This shouldn't take more than 15 minutes, and then the processing can maybe take about half an hour. Who's ever heard of processing? You've heard of it? Have you done it before? It's brilliant. It's really awesome. I actually had a crazy thought today that we might swap out C# for processing instead. It's so cool. But I don't know. I have to talk to Mark Foley about it because he wants me to do Python. So maybe we'll. I don't know. Well, I'll talk to Mark Foley about it. It's probably going to be C#, right? Anyway, so the first thing, can anyone just, before I start as well, was there any particular issues that people discovered in the lab? Any things that kind of, yeah? Not overflow 200, is it?
Yeah.
No, that's okay. In terms of, was there anything like the for loop splits, the while loops? Are people okay with that? You're just, if there's any particular things you want me to talk about or focus on in today's tutorial?
On the first one where like you do the 10 spaces and back.
Yeah.
We could only do it in 2 for loops, but the lecturer said, the lab supervisor said we were able to do it in 1.
Yeah, you can do it with 1, but it's a bit messy to do it with 1. It's probably, in my opinion, the optimal solution is to use 2. How many people use 4 for loops? Like did a for loop to go out this way and then 2 more for loops to go back this way? How many people did it like that? Huh? What's that? Or how many people did it with 4 loops? Like a loop to go out like this and then a loop to come back in again?
Yeah.
How many people did it with 2 loops? So you just basically had, you guys have an if statement in the middle to decide the number of spaces or something like that?
So I started an array with
Right.
space and the bigger and the bigger and the bigger. And then I just used the for loop backwards, so we just printed the big one.
Awesome. That's a really cool solution. I would never have thought of that. Cool. Oh yeah, so sorry, just before I start this then, quick point here, look at this. For those of you that, how can I start at this slide here?
Double click.
How do you start at this
Just double click on it.
slideshow? From current slide. Look at this. This is a data entry clerk. Data entry clerk earns minimum wage, right? And sits in front of a computer all day typing stuff in. This is a programmer. Programmer earns about 5 times as much as a data entry clerk. So what do they do differently? Look at them, they look the same. This is like a guy who started off as a data entry clerk and then gone off and got a computer science degree and suddenly discovered his salary's gone up 5 times. What's the difference?
One thinks.
That's it exactly, right? So this guy spends all his time sitting in front of the computer typing in. This guy spends, I'd say, about 20% of his time typing stuff into the computer and the rest of the time thinking about the optimal solution. So can I just ask a question again? How many people started the lab on Thursday by firing up Visual Studio and starting to type in code straight away? Alright. So I don't recommend that strategy, and I might actually just, when the lab becomes something tricky. I'm going to do another one which involves developing an algorithm and loops and stuff this week. Yeah.
Counts for typing while thinking?
You can't do it. I mean, it's just, you can't multitask like that. I can't anyway.
What I normally do, I do my startup, then think about it.
Yeah, that's okay.
Then type what it just fall up.
That's fine. Or if you type really slowly. So you're actually typing but thinking mostly. Yeah. What's that? You only get 4 euro an hour. Okay. Yeah, we need to work on that. Right, look at this. This is a PowerPoint slide of a really great programmer. Really great programmers spend very little time in front of the computer and all of the time doing other things.
Yeah.
What? No way.
That's so pissed off.
2 hours and 10
Good programmers write very, very little code. And the better programmer you are, the less code you actually write. Did you know that? That's a fact, right? In fact, there's a quote which a computer science lecturer used to use with me when I was in college. The best line of code you ever wrote was? you didn't have to write. So think about that, right? So if you solved your problem using, like, here's the thing, I did notice one or two people, I'm just going to create a new project here and I'll show you. And we'll definitely show you processing, right? Just going to create a console application there. A couple of people started this, right? Which is definitely a solution, and it will work, and it's correct, okay? Console dot write line. Space. I love DIT. Okay.
Copy cheat all the lines.
Okay. This is a solution. It's technically correct, isn't it? Hey, that's cheap. You get what I'm going there? That's a solution. That is code. But I would say that that's code. That's not good. It's not a good way to solve it. Because what if you wanted to? I mean, it's a bit of it's a toy example. But what if you wanted to print something instead of I love DIT? You got to go and make 20 changes to the program. You follow? Okay. So I'll give you the solution that I used. Okay, and I think it's pretty optimal, but no doubt some of you guys will have come up with better solutions. So first thing I did actually, and first thing you've got to do is look at the problem and see what's happening. So I won't bring it up now, but if you remember, what happens is you've got something which is repeated. Okay, so it says I love DIT, and we can see that it prints that 21 times. So straight away I know I've got what? Yeah, but when you see something repeated, what does that tell you? What type of loop is it? A for loop or a while loop, or does it matter? Why a for loop?
Does it increment send decrements?
Yeah.
But I kind of problem with it for some reason, like something printed as 4 lines and like it was old, right? I couldn't find the same.
If that's the case, then use the debugger. Set a breakpoint in your program and you will discover exactly.
I don't know, I think...
Well, it never happens for random reasons. There's a reason why. There's something in your code that's caused that to happen. And when that happens, you use the debugger, press F9, toggle the breakpoint, and you can see your program stepping through line by line and say, aha, it's got into this thing, and I thought it didn't, follow? Anyway, I would say a for loop is the one to use in this situation, and the reason why a for loop is the one to use in this situation is because
How many times do
you know in advance how many times it's got to execute. A while loop is generally better if you're not sure how many times you want it to execute.
Yeah.
So for example, if you're reading from a file, or you're reading from a network, or you're reading from a keyboard, you might use a while loop because you don't know how many times it's going to execute, because you don't know how big the file is, how much data is going to come over the network, and so on. So we'll write a for loop, okay? For int I equals 0, semicolon I is less than 21, semicolon I plus plus. Alright, so that's going to execute something 21 times. Each time I execute that, I also need to loop because I need to print a certain number of spaces. Isn't that right?
Yeah.
So again, I know in advance how many spaces I'm going to print, and it's actually going to be controlled most of the time by the variable I. So up as far as halfway along, it's just the number of I spaces that I need to print. And then after that, I'm going to have to make some different decision. So why don't I just go int num spaces is equals to I. And then I'm going to write another for loop for int j equals 0, semicolon j is less than num spaces, semicolon j plus plus. And now I want to do console dot write line, and I want to print a space. Not write line, I want to use write, because I want to print a space but with no carriage return at the end, and that's the difference between write and write line. Everybody understand that? So, okay, I then want to print a certain number of spaces, and then I want to go console dot write line, I love DIT. Alright, so we try it and see what happens now. Now it's going to go all the way out, it'll never go back in again because it's just being controlled by the variable I. A couple of questions that people had, how do you get your program to pause? Two different ways. Number one, you can just press F9 at the last line of code in a method. Notice that it will let me put a F9 here, but I can't put F9 here because this is actually not code. There's no code there. Alright, that's actually just the definition for the class. And similarly, you can't press F9 here because there's no code. That's not actually executable. The only executable bit is inside the method, the main method. So I can press F9 there. My program will pause. Another thing you can do is do console.read line, which will read a line of text from the console and wait for you to press something. Is that okay? So, I'll just show you that. Both ways. Console.read line will do the same thing. That reads a line of text into a string. So that will also cause the program to pause. So if I press F5 now, the program runs and I get this. What I want to do now is I want, as soon as I reach 10 spaces, or as soon as I reach 9 spaces, I then want to start going backwards. And to start going backwards, I could just go, and well, the way I did it was this. I just said, if I is less than 10, so I'll initialize that to be 0. Num spaces is equals to I. So in other words, as I'm going up, right, num spaces is just equals to I. But then once I becomes greater than 10, I actually want to start it going down again. And I know that I've got 21 lines in total, so I can just go num spaces equals 20 minus. And if you think about it, once I becomes 10, I've got 20 minus I, which is 10. And then once I becomes 11, I have 20 minus I, which is 9. So that's going to start it going in the opposite direction. Everybody follow that? So up as far as 10, it's num spaces. From 10 until 20, it's num spaces minus I. That's the way I did that one. It kind of works, I think. Is it 20 or 21? Well, that kind of works. So I've got 21 iterations of it, and yeah, because you have to do an odd number, don't you?
Otherwise you get like 2.
Yeah, otherwise you'll get a spare space at the end. Is that alright with everybody? Yeah, is that okay with everybody? Yeah. If I go too slow or too fast, just let me know. Alright? Yeah. No worries, this is going to be, I'll put it on the website.
Oh, okay.
But by all means, if you want to try to type it in now, go ahead. But I'll put this on the website and I'll comment it. I have the solution here. You know, it's the program that I wrote on Tuesday's class is up on the website, and it's all documented as well. By the way, everybody knows what a zip file is, do they? So all of the projects that I put up will be a zip file. You can't just double click on the zip file and then click on the solution into it. You have to do what? You have to extract all the files somewhere first. Is that clear? Okay. That's the first one. Second one was the Fibonacci. Now, there's a million ways to do the Fibonacci series. The way I like to do it is like this, okay? So if you remember the Fibonacci series, the first few numbers are 0, 1, the next number is 1, the next number is 2, the next number 3. So you take the previous two numbers, add them up together to get the next number in the sequence. Alright, Fibonacci sequence number is a very interesting number, or the very interesting sequence of numbers. Where would you like to encounter Fibonacci numbers?
In Chicago.
Yeah, give me an example.
Snail shells or some shells firing out.
Possibly, yeah. I mean, quite possibly. The one that I'm just ready with myself is the number of seeds in the head of a sunflower is always a Fibonacci sequence number. Isn't that amazing, isn't it? So it's a natural thing, right? And these numbers appear in nature quite a lot. Where else would you encounter them in fiction? In the Da Vinci Code, of course. Right. So the way I did this was I basically just keep track of two numbers. The previous number and the number, the previous two numbers, and I actually call those previous is equals to 0, and then the current number is equals to 1. Alright, so this is the first two numbers in the sequence. I'm kind of seeding it, right? And then I actually need to, because this isn't going to print the previous number, it only prints the current number. I need to print the first previous number until the current number becomes, previous number becomes current number. So I need to start it out, right? So console.write line, and I'm just going to print 0 in here. And then I go into my loop, okay? So while the current number is less than 200, because I only wanted to print it up to 200. What's going on there? Oh, an extra bracket. Okay. So I want to print the current number first of all. Okay, so now I've printed 0, now I've printed 1. I now need to kind of advance things to the next, so I need to kind of swap them. I need to make my previous number into my current number. And my current number, in fact, the first thing I need to do is make the current number equal to the previous two numbers summed up together. And then I need to make the previous number into the current number.
What I would do would create another integer.
Yeah.
Which we call sum, the sum of the two values.
Okay.
And
Wait, let's do that. Because I did it a different way, but let's do that.
Sum is equal to current plus previous.
Yeah, good idea. So then you print the sum rather than you print the current one, yeah?
Yeah.
Much better.
And basically, then you can say
Yeah, that's a good
current
idea
is
as well.
equal to sum, or previous is equal to current, and sum is equal to.
You need to do that in that order, because otherwise you lose the current one,
Yeah.
don't you? So you need to go previous
Yeah.
is equals to the current number.
Yeah. And
And then
current
you
is
go-
equal to sum.
Okay, that'll work as far as I can figure out.
In sum equals current plus pre.
Oh, it's pre rather than yeah, cool. Alright, that'll work. I'll show you the way I did it, which is slightly different, but it's exactly, it's the same thing. You need to have a spare variable in there.
Right.
Yeah.
Rather than printing out 0 at the start, could you not have used the prem as what you were going to print each time?
Yeah.
Instead of the sum or anything like that?
Let's try it now. Hang on a second, just make this a compile. Have I got an extra bracket there? Oh, I closed the thing here instead. Okay. These things should be all indented. Work?
One more.
Okay. Right. Go. Infinite loop. Oh no, hang on. By the console not read line, sorry.
Yeah. Put it at the end.
Yeah.
Well, that's actually pretty on numbers, though.
Yep. So we get 0, 1, 2, 3, 5, 8, 13, 21. So that's correct, I think, yeah.
Why is it 1 over 2, 2, 3?
Oh, I've got it up too high.
And it's
What should I do instead? Instead of sum, print previous.
No, while previous is less than 200.
Yeah, just drop that down to 144.
Okay.
Great.
Oh, that.
While your current number while previous plus current investment.
Oh, that's messy.
Bring
That
the
means you have to
current.
do an extra operation. Yeah.
Right, I just changed it so that it said current is less than 144. So that it got to 144, did the final calculation,
Yeah.
and then didn't go to 233.
So the problem with that approach, that will work, right? The problem with that approach is somebody reading it is going to think it goes up as far as 144 unless they take the time to study the code. If you look at 200, it's going to, you see, yeah, 200 is a magic number. Yeah.
What I
Do you
did
know what I
was-
mean? Just makes it a bit less readable.
What I did was I printed at the start of the while loop and added at the end. So it would print at the start, so it'd read 144, and then when the loop came back around, it'd be over 200, so it wouldn't print that.
So how, sorry, just talk me through that again.
So if you have the console write line at the start before you actually add the two numbers together,
Okay.
and if you have
And what am I printing?
Current. Current.
mm,
No, you want to
And
print the
current
0 value
less than
first.
200.
And while,
Current less than.
I don't think that's going to fix it, but it
Yeah.
might do.
Yeah, it's working.
Change the printing to previous and you get rid of your initials, right, 0.
So I change the printing to previous. Oh, that might work.
Yeah.
no, it won't.
And then I get rid of this one.
Yeah.
Yeah, because the first previous is going to be 0. I think that might work. I think it's weird.
No.
Nope.
Print the current.
They have 144.
No, you need to
Print
some-
current.
Print current.
Yeah.
Then I'm back to my previous problem. Okay, I'll show you how I solved it. Which is slightly different. What's that?
When I was coding in the lab, I got work on my U drive.
No props. Well, okay, so what I did was I got previous and current, and I put it back so that I actually seeded it by printing 0. Then I printed the current. Okay, that's the way I did it.
Sorry.
Now what I need to do is make the previous equals to the current, and the current has to be equals to previous plus current. Alright, but in order to do that, you need a spare variable, because you're overwriting current. Follow?
Yeah.
Because so you need to, first of all, go into temp equals current. Okay, so I'm basically storing the current value into a temporary variable, and then I go current equals current plus the previous value, so I'm going to sum the two of them, and then I go previous equals current. So I've kind of rearranged things. That's how I did it.
Previous equals 10. Yeah.
Sorry, previous equals temp, yeah.
You could also make it the other way around, say previous is equal to current, and afterwards say current is equal to current.
Say again, previous is equals to current.
Oh,
Okay.
No, you can't actually start.
No, you can't, because then you can't add current to previous, yeah. So that's the way I did it. And I think that works. And then you can also go if current is less than 200. And again, just from a readability point of view, it's better to say 200 rather than 144, because if somebody's just doing a really quick look over your code, they'll see that 200 is the sort of magic number that you're working towards. Numbers, not right?
Yeah.
Because it has imaginary roots. You know about imaginary numbers? Like the square root of minus 1 multiplied by something. Anyway, we don't need to worry about it. We have another value here which we call the discriminant. And then we have potentially two solutions. So you got float x1, comma, x2. And they're the two values that we're going to
X1.
What's that?
They're both X1.
They're both x1, thank you. And, you know, this is a good strategy. Just make sure everything gets initialized. It's not wildly important. But your program won't compile if you start using these variables. Anyway, so the first thing we use, we calculate the bit under the square root, which is the discriminant. So the discriminant is equals to b squared minus 4ac. So how do I do b squared?
B times B.
B times b is a very good way. So b multiplied by b minus 4.0.
Minus.
No, it's just
B minus 4. Yeah, but that's, oh yeah, 4, sorry. Yeah.
minus 4, minus would be just plus.
Yeah.
So it's multiplied by a multiplied by
C.
C. So that's the discriminant. And then we check the discriminant. Because if the discriminant is less than 0, it means there's no roots, okay? If discriminant is less than 0.0f. What is going on with the brackets today? Huh?
I think you're again outside.
Oh, maybe you're right. Oh, you're right, sorry, yeah. So all this stuff should be indented a bit. Discriminant is less than 0. I'm going to say there's no roots. So there's no real roots. Otherwise, if you like, you can check to see if the discriminant is equal to 0. If the discriminant is equal to 0, how many roots are there?
1.
There's exactly one root. Okay, I'll show you something which might just explain what does that mean when there's only one root. But actually, I'll just do that now, right? Just interestingly, if you're wondering what does it mean when a quadratic equation only has one root, this is what it actually means. If you in geometry or whatever take this, what do we call that? Circle. Yay! Okay, so that's a circle, and this we call a line, right?
Basically, it's a second point where they want to touch once.
You got it, right? So there's either three possibilities for these things intersecting, isn't there? Either you have this situation here where they don't intersect at all, and when you do your quadratic equation and work it out, you'll find that there's no roots in this situation here. If they intersect and this one just glances off, there's one point of intersection. That's where you get the bit under the square root sign being equals to 0. In other words, there's only one point of intersection. Alternatively, you've got 2 points of intersection. And that's what it means to say that there's no roots, there's one root, or there's 2 roots. Is that alright? Just to aside. So otherwise there's no roots. You can check to see the 0. Otherwise what we do is we calculate the two values for x1. So first root, x1 is going to be equals to minus b plus the square root, which is math.sqrt of the discriminant 0f y by a. So that's root number 1.
You put the first half in brackets.
Doesn't really matter because this is in brackets, so it'll do this and it'll do the other bit. So I think it's okay. Huh?
You need the minus b to be divided as well.
Yeah. Say again? So I should just put brackets right here. I don't think it makes any difference. Did I do it in my minus b? Potentially, it's no harm to put it in. So that will work, won't it? Okay. So we have minus b minus that, and then we can print those values out. So that's it. Okay. If you wanted to, for example, you could check to see if the discriminant was equals to 0, in which case you wouldn't have to do the plus and minus bit, because the square root of 0 is just 0. Alright, that's it. I want to show you something cool. Is that okay with everybody?
You also need to pass it out.
Oh, sorry, you're dead right. Yeah, shift control me, and I should get an error, potentially. Well, there's one already. Bracket missing. I really want to get you guys, and here's the error you get, right? I'm going to show you, sorry, just one thing before I go finish this bit up. C# is very strict about converting from one type to another, because you can lose precision when you convert from a double to a float. How many bytes is in a double? 8 bytes. How many bytes is in a float? 4 bytes. So it's saying, hey, this method here actually returns a double, and you're converting it to a float to do the rest of the calculation, and eventually assigning it to the float. So it says, hey, you got to be careful when you're doing that, and I'm only going to allow you to do it if you acknowledge the fact that you're doing a conversion here and accept the consequences. So the same thing happens when you convert from a float to an int. It doesn't happen in C, it just does the conversion without giving you any errors. But in C# you have to do that. And then, just to show you really quickly, because I do want to show you some processing, just really quickly. If you wanted to get the user to type in those values from the console, readline. Okay, so that will read a line as a float. But you can go float f equals console.readline. That ain't going to compile because this returns a string and this is a float. In C# to convert from a string to a float, what do you use?
Try parse.
Float dot parse. So that's a method. It's a static method on the float class, which we'll get to all of that at some stage. But that will convert from a string to a float.
Convert that to single.
Oh, you could use that as well. That will do exactly the same.
No difference.
No difference. It's exactly the same, right? Okay. Is that alright with everybody? Is everybody happy to do all the C stuff that you would have done last year? I mean, apart from structs and pointers and stuff, to do things with for loops and while loops and if statements, and also all the operations on variables. Maybe on Monday I might just go through stuff like pre-increment and post-increment before we start doing some more stuff on the C# strings. I really wanted to show you guys this thing, because just at the start of the summer we run a thing here every year called the DIT Computing Academy, and this year I decided to teach this thing called processing. So processing is absolutely amazing. It is based on the Java language, so you learn OO programming or whatever in the process. But, you know, I had one afternoon with these students, and by the end of the afternoon we had done what normally takes in C up until Christmas time. The while loop, the for loop, the if statement, 2D animations, graphics. It was awesome. And they all learned programming. I mean, they've probably forgotten it now, but if they kept it up, they'd remember it. Look at this. Here's the HelloWorld processing program. Now, I want to find a way to do this in C#. I wanted to draw pictures in C. Right? So, you can go line 10, 10, 50, 50, and just type it into processing. And you can download this for free, okay? It's called processing. You go to processing.org. Every processing program is called a sketch, rather interestingly. So there, that's my HelloWorld. And look what it does. It draws a line. Alright. So, what do you think these parameters are here? This is clearly a method, isn't it? Or a function, as you would call it.
X and Y coordinates.
They're X and Y coordinates. So what do you think 10, 10 means what?
Start.
Start of the line, and then 20, 50, 50 is the end of the line. Interestingly, in graphics, the origin is always, or almost always, in the top left-hand corner, rather than the bottom left-hand corner, like you would have expected. So that means it goes over 10 and down 10, then over 50, down 50. So there's that one. And then you can also put in some other things here. I need to get some processing sketches here. Like if you want to have a bigger screen, there's a method for doing that, and it's size. So I'm going to set the size of the screen to be 500, 500. And so now I get a bigger screen when I run the thing. And then you can set the background color. So I'm running through this really quickly, but we would have spent a lot more time on this. To set the background color, you go background. C-K-G-R-O-U-N-D. And this takes either one parameter or three parameters. There's two versions of this method. So the one that takes one parameter, it's a value between 0 and 255. Yep. What do you think the parameter indicates? If it just takes one parameter, single number between 0 and 255. What would it indicate? Shaded grey. Okay, so if it's 127, you get like completely grey. If it's 255, you get black. Would you get white or black for 255? You get white. Okay, because it's full intensity white, and then 0 will be black. Okay. Alternatively, you can pass in three numbers. What do you think the three numbers indicate?
RGB.
Red, green, and blue. Exactly. So 25500 would be. 255 would be
Red.
red, no green, no blue. And you can mix up any color using that's called RGB. Okay, so that's how you set the background color. So if I want a red background, you can go 255, 0, and 0. There's another method here called stroke, which changes the color of the pen that's used for drawing. So if I want a red background and green text, you go 0, 255, so you get all green. And you can mix up your colors like that. So yeah, whenever with my processing sketch, you get that. So pretty quickly, you know, I mean, I've got something drawn on the screen. This is the HelloWorld in processing. So once you want to start doing interesting things in processing, it makes sense to put in some methods yourself. And there's actually, you can create as many as you like. You can create classes and stuff like that, but there's two kind of built-in ones. There's one which is called setup. Setup is stuff that happens right at the start, and then the second one is called draw. So you can say, only do this thing at the start. The draw method gets called 60 times a second, whereas the setup gets called just once. So that's the same program separated into a setup and draw method. So I got setup there, and then draw. So there we go. Oh, yeah. Maybe that's not meant to be in there. Maybe that's meant to be in the other one. Put this up here. Okay. Happy enough with processing so far? What's generally the next thing you do in programming after you... What's the first thing you learn in programming?
HelloWorld.
So this is after the HelloWorld. What's generally the next thing you learn? Variables. Okay. Interestingly, processing has a number of built-in variables. And then there's ones, of course, you can declare yourself. So let's do some of the built-in variables, mouse x and mouse y, tell you where the mouse x and y coordinates are. So instead of, we'll say, you know, let me just replace these with mouse x and mouse y. So now these are variables. So I can see that when this is getting executed 60 times a second, it's going to start a line at 1010, and then it will draw a line at mouse x and mouse y. So now I get this. You can see, can everyone 100% understand what every line in this program is doing? What if I wanted to get it to clear the screen in between the draws, so I just get, you know, some kind of animated effect? Just looks like it's drawing one line.
Background.
Yeah. Just change the background, or put the background call in here. In fact, I should really do that. That doesn't matter. That would be fine. So now I'll get this animated line. Because it's wiping the screen and now it's redrawing every time around. Interestingly, there's lots of other drawing calls you can use. For example, you can use this. IRCLE. And this takes 3 parameters. What do you think the 3 parameters are?
An x and y point and then size or diameter of
The x and y, and it's actually the radius as opposed to the diameter, right? So let's do mouse x and mouse y for this. In fact, let's not do mouse x and y. Let's pick the center of the screen. So I know it's 500 by 500. So let me do 250, 250. And in fact, There's one extra call in here, and that call is fill, which changes the fill color. So that 250, 250, and I can do this 50. And then let me change the fill color. Oh, hang on, it's not that, it's ellipse. What's the difference between a circle and an ellipse?
You can change the X and Y.
Yeah, so an ellipse can be a circle, but it can also be a squashed circle. So it can be a circle which is not the same height as it is width. So you could do ellipse, and then you can do fill. So let's say I want a blue, so that's going to be 0, 255, 0. And then I get a little ellipse in the circle center of the screen. Look, blue thing. So let's do something interesting here. Let me try.
Can you say fill dot ellipse?
What's
So
that?
if you wanted to draw a square and an ellipse, but you wanted the square to be filled with red, could you say fill dot ellipse?
No. What you would do there is you'd set the fill, draw the square, set the fill a different thing, and then draw the ellipse.
Oh, okay.
Alright? You can also use mouse X and mouse Y in any of these here as well. So pretty quickly, you know, you got 1, 2, 3, 4, 5 lines of code, and you can do this. Wow, trippy. Right. And then you can animate things as well. So I could declare some variables up here. Float x equals 0. Float y equals, let's say, halfway down, which is going to be 250 down the screen. So then I can go ellipse x comma y, and I can go x equals x plus 1. What's going to happen now?
That's gonna move.
You're going to get a little animation. Look at this. Trippy. So you can do simple things like that, you know, understanding how variables work and stuff. Pretty cool things you can do here. You can also say, use these variables in here. Oops. So I can put this variable in here, so I get different shades of, let's do this one. Let's do that one as y, but let's do it as minus mouse y. Sure the hell of it. What am I going to get here? I'm going to get blends of green and blue mixed up together in weird ways, depending on how I move my mouse around. Wow. You know what? Let's try changing it a little. That's not very interesting. Let's make it a bit nicer. Okay, now I get a bit more interesting shape. So anyway, after, you know, half an hour, they were drawing the Starship Enterprise, getting the Starship Enterprise to move from one side of the screen to the other, which of course is what all programmers should do. Always. Yes. There are random things as well. And then, actually, very interestingly, I had a group from a girls' school, and I said, do you want to do more programming, or would you like to do some maths? And what did they say? They said maths, amazingly. So that was really delightful for me. So then we talked about sine and cosine. So, and this is kind of the program that we ended up with. If you plot a sine wave, right? If you know sine and cosine, we'll do this later in the course, but very interestingly, sine and cosine, you can calculate points on the outside of a circle by using sine and cosine. If you just plot the sine function, what does it look like? It looks like a wave, right? So it goes up and down like this. So if you increase the x but use the y to do a sine wave, you get really nice shapes. So what do I do? Because I'm not sure if I have this one printed out, so I'll just try and. Okay. Yep, this worked. Okay. So what I want to do is declare a variable called theta. Now I would explain this, but we don't have a lot of time. So I can go theta equals 0.0. That's going to start my sine wave function at 0, and now I want to add a little bit to it, so that as it's, you know, calculating, I want it to generate the actual wave, right? So theta starts at that, and then I can say my y is going to be equals to 250. Now, how high do I want my sine wave? Well, you decide, right? And that's kind of called the amplitude of the sine wave. So let's say the amplitude of the sine wave is equals to 60. I think this is what I did. Yeah. So my y is equals to math dot. Where's the sine? Oh no, it's just sine. No math dot anything. Equals sine of theta. plus 250. And let's say the sine of theta divided by the amplitude. I could explain how all this works, but it's not really relevant. No, we don't have time. It's really simple stuff. Sine of theta multiplied by the amplitude plus 250. I think that should be okay. And then let's say I want to draw my ellipse at x and y and do it at those particular colours and just see what the hell. Let's try it and see what happens. Nothing. Oh! Whoa. X equals x plus 1, y plus sine theta multiplied by... Oh, what have I forgotten to do? Increment theta. Plus equals to 0.1. So I'm going to add 0.1 of a radian to it. Use this radians. Huh?
You need an F after 0.1?
Yeah, I should really put an F there. I think it'll work without it, but... Oh. So now you get this thing going on here. This is much more interesting if you don't clear the screen each time around. So you can basically see, instead of adding 1, let me add 2. So we get a small gap between the x's, and I'm going to get lots of nice circles getting drawn here. And then let's also do random colours. Instead of doing this, let's change it to be random 255. And then, let's do one last thing and then we'll finish up, right? What's quite interesting to do is basically to set the radius. Let's say the radius is equals to 100. And then what I want to do is subtract something from the radius, okay? Well, let's just the radius. How do I subtract from radius? Minus equals to 2. Fine, so let's do radius minus equals to 10, and then we'll do this. Instead of using mouse X and mouse Y, let's use radius, comma, radius. I'm sure, let's see what it does. Hey, maybe 10 is too big. Let's do minus equals to 1. Like it? So, you know, they were able to do all kinds of really beautiful patterns and geometric shapes and stuff. And you know what? It's just programming. It's the same stuff you guys already know. It's just drawing nice pictures. We'll leave it at that for today. Okay, that's called processing. Yeah.